This is Trish Ward, Director of Learning and Development, and I am back here with Karan himself, and he is going to explain to us how we actually define the healthy population that we talk about on BiomeFX.
Yeah. Hi, Trish. The healthy population is really important because that's what we're using to map the presence and the patterns of the rest of the microbiome. The healthy population actually comes originally from the Human Microbiome Project itself, and the American Gut Project, and a couple of those large global sequencing projects that have happened and started since 2007. So there are about 426 really clean data sets for healthy, normal Americans. There are more when you include other global populations, but it's important to map your results to the geographic location that you're living in because that has an influence on your microbiome. So what does that healthy population look like? It's basically people who are free of chronic illness, right? And obesity is included in the chronic illness. Any sort of chronic illness is being managed by a medication or a genetic chronic illness or something that's congenital that they've had since they've been born. They have to be free of all of that to have been categorized into the healthy population category. So these are people that don't have any chronic conditions. These are people who are not being managed for any medical conditions. And that is the FDA definition of a healthy population. And that's how the Human Microbiome the Human Microbiome Project characterized these people. Now, their data, their whole sequencing data, is available to companies who have the capacity and the capability to read all of that huge terabytes of data and interpret it and mine it for information. What Cosmos ID does really well, which is one of the reasons why we wanted to work with them, and we'll do a whole video as to why we wanted to work with Cosmos ID, but what they do really well is the ability to mine, interpret, and understand huge chunks of data, right? So when sequencing technology came about, one of the things that was really apparent is that this is a big data problem, meaning you take one person, and one person has so much sequencing data that it would clog up the top computers that you can buy for your desktop. I mean, we're talking about terabytes of data from one sequencing analysis. Imagine if you had 400, 500, 600 of those data sets. You've got just billions and billions and billions of data points that if you don't have the microbial ecological understanding of how to work with that data, interpret it, understand it, put it all in context, then it's just useless bits of information, right? So Cosmos ID has been digging in since 2004 into those data sets every time they're available, and they've been mining it and making sense of the data and mapping it and so on, and they've created the most elaborate and accurate US healthy population data set out there. And that's what everything is mapped to, right? So that gives us the ability to understand ranges. Now, all of that is also correlated to data sets of sick populations, right? For example, if the healthy population data set says that this is where the typical alpha diversity is for the US healthy population, that is meaningful, right? So even if you have 430, 440 samples that correlate that say all of these people have no chronic illness and their alpha diversity tends to be here. And to give you a demographic explanation of that, it's a big spread of people. It's women and men about equal distribution. It's anywhere from 6, 7 years old all the way up to 90 years old. So it's a big spread. And remember, your microbiome is pretty well established as an adult microbiome around 2.5 years of age. So when it comes to the microbiome, it doesn't matter if you're a 9-year-old or a 70-year-old, you're still dealing with an adult-like microbiome. So you can collate all of that data together and look through it. So let's say they've mined and they found that the typical US healthy population, meaning people free of chronic illness, tend to have alpha diversity in this range. Then what further verifies that data is when they look at data sets of people with specific illnesses like Crohn's, colitis, because there's data sets on all of these types of conditions. Diabetics, there's huge microbiome sequencing data sets on that, on obese individuals, on people with IBD, on people with autoimmune disease. When you start looking at those data sets, and they show typically that those people map to being below this alpha diversity, then it further validates that this range of alpha diversity is actually a healthy range. Because not only is it present in healthy individuals, it's absent in sick individuals, right? So there's a couple of different ways of approaching and validating the data. Cosmos ID is brilliant at doing that, and the work of Rita Caldwell, which this is all based and founded on. And again, we'll do a whole video just talking about her and the amazing work she does. But that's where the healthy data set comes from. It's a big demographic distribution: men, women, kids, all the way to adults. It's all correlated, brought together. It's analyzed and mined really effectively by the types of technologies that they have. And these are people who are free of chronic illness. Wow. So that's the key here, right? And then again, just to reiterate, all of the data sets and the ranges are then further validated by data sets on people with disease conditions to validate that these ranges are actually found in only normal people. And typically people with conditions are outside of this range.
Okay, that's very helpful. Thank you so much.
Yeah, my pleasure. But it's a very important question. Now, they also have hundreds of thousands of not individual person sequences, but they have hundreds of thousands of data sets that they've been able to put together from different sequencing data from sick individuals, healthy individuals. They have looked at genome sequences inside and out, front to back, end to end, mapping it and correlating it with disease conditions. So they have a very, very elaborate database of all of that kind of information where we can go in and go, hey, what is the typical characteristics of somebody with Crohn's in the data sets that you have? And they can basically go in and mine the data and kind of figure out, here's how Crohn's individuals map, right, in terms of their microbiome. So really, really important databases.
Wow, that's fantastic. That's amazing, actually. Truly impressive.
Yeah. Really important, and really important for us to understand where you fall in reference to the typical healthy population. As certain aspects of your microbiome fall out of that range, it presents certain risks, right? And so, and the beauty of it is a lot of this is correctable. Yes. There are things you can do to bring it back in range, also validated by published studies and all that. So it's really important, and maybe this is a good time to say that all of the recommendations that we provide in the test, the lifestyle, the diet, the supplemental, all of those are validated by studies as well. We don't put all of the reference on the test report because it'll be a 400-page test report. But if anyone ever wanted to look at the references, we have a list of all of it. So it's not just like, frou-frou things that we came up with. It's actually things that our team has spent endless amounts of hours searching for studies that validate ways of impacting these changes in the microbiome.
Wonderful. Thank you.